Good afternoon, everyone. Good day, good night, depending where you are looking from. And welcome to this CGVinny Coffee break number 6. Today, we are here to talk about Substance 3D Designer, yes, to make an introduction around the software. This is our oldest software in the Substance 3D collection, and it's also kind of the heart of the Substance 3D ecosystem, because you can build, of course, materials, but also lots of tools, filters that are going to help other software like Painter, Sampler to work better. Before we start, let's look at the chat. There is kind of some people right now. So hi to Shani, Komodo, Jeps, Cortez. Yeah, people from India, from Canada. Don't hesitate to tell me where you are from. I'm interested. I'm from Barcelona. It's super hot right now. And let's go. So let me share my screen. My face is at the right place. So Substance 3D Designer. This is a software. I'm just going to remove my headphone because I have the music and it's not good for me. So Substance 3D Designer allows you to make lots of stuff, of course. It's mostly known at first for making digital materials, but it can do way more. But today we're going to focus on the materials. So Mao from, okay, based in the UK, but from Italian. I said ciao, Mao. So let's see first the welcome screen, which you should have. You should have this one. This is the latest version. I think it has been updated something like 2 or 3 days ago. On the top, you just have a welcome image with a place to go to the Substance 3D tutorials, because of course I'm making this one, but you have way more in the Substance 3D tutorial channels. So just look. I like to do live stream also to interact with you in case you are doing it at the same time. I'm going to try to be at the pace where you should be able to follow in case this is recorded, so you can still go back to the replay afterwards. Just below this welcome screen, you have the recent files that I did or that you would did. So as you can see, I made the same live stream in French and in Spanish 2 days ago and yesterday. Bottom left, you have some interesting shortcuts, so to know more about Designer, but you don't need it today because I'm going to explain everything. You can go to the online documentation, the website, forums, etc. What is interesting us at the moment is the top left, where you have the option New Substance Graph. As you are going to see, the scene where we are going to work is called a graph in Substance Designer, and by default it's a material graph, PBR exactly. We are going to see that. You can open a package if you already have one. You can create a MDL graph. We are not going to tackle this today. This is really something quite exclusive. And you can import AXF, but once again, that's not why we are here today. So let's start by clicking on New Substance Graph. If you have any question at any point, I have the chat in front of me, so don't hesitate to interrupt me. I will answer almost directly. So New Substance Graph, as you can see, it's a bit daunting at first. There is a lot of information. On the left, you have templates, which are models of graph to start from. And on the right, you have the properties for each template. So as I said, it's a bit daunting. So why are there so much presets? Because there is different ways to make a material. And even if there are some major tendency and major models, there is still some difference. So we want to tackle everything. But what you have to retain for material is that it's based on something called PBR, which means physically based rendering, which is something that allows you to create materials that would mimic the reaction of a material with the light that you would have in a real world. So it's a bit physical. You don't have really to care about the physics underneath that, but it's good to know. And within these PBR materials, there is 2 major ones which are right now used everywhere. There is a model which is called metallic roughness, and another one, specular glossiness. Metallic roughness, something created by Disney, is the most used, I would say, because it's fairly easy to understand. Regardless of that, these are just way to interpret and give information to represent a material. You have something in an engine, for example, a game engine, you have something called a shader, and this shader will display a material, but you have to provide more information, and that's what Substance Designer is preparing. It's preparing maps, textures, it's called, you can call them map, textures, or images, but generally it's maps, and they are going to provide information about different aspects of the material, like whether it's the color, if it's matte, if it's shiny, if it's transparent, if it's emit lights or not, etc., etc., etc. There are many aspects you can discover. We won't tackle everything today. We'll make a simple material, but you have to know that it's possible, and you have to give this information, and that's what Designer does. So, as I said, there is the metallic roughness one. We could take this one. We also made one recently, which is called the Adobe Standard Material. So don't worry, we didn't create a new genre here. It's based on metallic roughness, this one, but it allows us to make sure we are displaying and creating a material that will be displayed the same in all the ecosystem, and also we can document it. There is like a documentation online. So for example, if we work with I don't know, Autodesk, Blender, or whoever who wants to use a substance material, they can look at how we specify everything. So this way you have a better interoperability between software. So we are going to look at this one and look at the property on the right. So the first one is easy. It's the name of the graph. What we are going to create is a package, and in this package there will be a first graph. So we can give a name. So as we see yesterday, I called it, if you speak French or Spanish, I called it my first graph. So let's do the same, my first graph. You can give the name you want, and you can even change it later on. That everything that is here, you can change it later on. There is a parent size. So maybe you're asking why it's called parent. I'm going to explain this a bit later, but when we say parent in Designer, it's parent application. Once again, I'm going to explain this a bit later. You can leave it at 248 if you have a good machine. If you have like a slow machine, maybe you can go down to 124, for example. Once again, this is something that can change later on. Substance Designer is a procedural creation tool, which means that everything that you do, you can tweak it afterwards. It's completely non-destructive. Output format relative to parent. In 90% of the case, you are going to leave it this way, 95. Once again, we'll see that later. It's a new package, so we don't touch that. And here you have some information about the template first, and then you have all the outputs that are going to be created. So with the name for designer, the name for the user, and what are they made for. It's like tagging them. So you are going to see that there is lots of outputs that are going to be created. So let's click on OK. And you should have this user interface right now. So what's going on? Lots of stuff. As you see in the middle, we have the main part where we are going to work. This is called the graph. In Substance 3D Designer, we are working in graphs. So I'm going to go back to this. What you have to know is that we'll see the navigation later on. On the left, top left, you have your package that you have just created and the graph that we name within this. This Explorer section will contain all the resources which are currently used in the scene. It can contain 2 packages, 3 packages, and each package can contain different elements as well. So once another substance graph, another MDL graph, bitmap, vector graphics, etc. Bottom left, you have the library, which contains lots of resources, which are called nodes, that allows you to work. So this is all the potential resources that you can use to build a material or a tool or to be used in your graph. Just on the right, you have the 3D view, which displays the material which is on your graph. In this one, you can change the object by default. I'm going to do it now because I like the rounded cube. I'm going to put this one, but you are going to see that I'm changing time to time depending on what I'm currently building. On the right, here you have the 2D view. This view displays the bitmap which is generated by this square, which is called a node. We'll see that later on. And on the right, you have the parameters, the properties. So these properties are contextual. If I choose this node, I will have these properties. If I choose the graph, for example, I will have other properties, etc. So depending on what is selected, you will have different properties. So now you see also that at the top you have different kind of tools here. We are going to see that. But now we're going to focus on the graph. So the graph first, as this is where you are going to work most of the time, we are going to see how to navigate. So if you do a left click, you are going to see that you are going to draw a rectangle that allows you to select one or multiple elements on the graph. If you do middle click, you are going to pan. I'm just checking something. If you don't have a middle click button, I would recommend first to go on Amazon.com and buy a 3 mouse button, because if you want to work into 3D, you are going to suffer a lot if you try to work with a trackpad, or even the Magic Mouse is so-so, but this depends of the user. Some users are really used to it. But anyway, you have to have this middle mouse button. That's really useful. So this allows me to pan, and also the mouse wheel allows me to zoom. So as you have seen, we have a lot of squares here. These are called nodes. So you can select a node by clicking on it. You can move it. You see that there is, when I click on it, there are the properties which are there. And something interesting is that these nodes, as some of them as an output, it's like a dot on the right. And when the dot is on the left, like this is called an input. So first, I'm going to clean a bit this graph. As I explained, this one is based on the Adobe standard material template that we used. And it's made to represent any kind of materials. So there are many information. Like for example, if I go down, this is to make subsurface scattering, meaning like for example to represent the translucency of wax or skin, which is really special. But in my case, I won't use it, so I'm deleting it. There is also here to represent the coating. Coating is like, for example, on the car, the second layer of varnish. I'm deleting it because we are not going to do that today. The sheen, which is like this Fresnel effect that you can have on some clothes, for example, here on the sides. I'm deleting it. And anisotropy as well is like the brushed aluminum reflection that you could have. I'm not using it. And finally, we are not going to touch about the specular level, specular edge color. So I'm removing that. And the opacity, I won't use any opacity, which means that is it transparent or not. So I'm not using it. So now I have these 5 nodes, and I'm good with this to make a material. With this, you can do like most of the material, as long as they are not transparent or specific. So let's see how it goes. As I said before, in order to make a material, you have to provide information to the shader, which is a small program which is supposed to represent this material in a game engine. So in the metallic roughness format, what you have to provide, it's organized this way. Once again, it's almost by convention. They decided, okay, we are going to represent the material this way, and they made it in a way that makes sense, of course, and especially for an artist. So the first one is the base color, and it's the most obvious one because when you describe something, generally you would start with the base, with the color. But you have keep in mind when you think about creating materials and using textures like this one, that these are information. And in that case, it happens that the information is color, a color. I say this because here as well I have a color, but this won't be seen as a color, as a purple color, while used by the material. So here, color, you see that when I select this node, I have the parameters. So if I change the color, it's applied directly on my object. This one is pretty easy. The normal map, if you don't know what it is, it's a specific map that fakes relief when there is no relief, meaning that's one of the constraints we do have when working in 3D. Sometimes we want to limit the amount of polygons we are going to build a model, especially if you have a wall, for example, with a lot of asperities. You don't want to use polygons for everything because you are going to spend like 10 millions of polygons for each 20 centimeters. So that's where this comes in place, because what it does, it fakes the lighting, it fakes the geometry. These are just vectors. So what it says when the light is, when the light is bouncing on a part, instead of saying, okay, it's flat, it says, no, here it's not flat, it was this way. So it will deviate the light and it will give, it's pretty good at that. So I'm going to show you, for example, it just needs, for this normal map node, a black and white input. So I'm going to take one. Don't do it right now, it's just to show you. If I take this one, for example, I drag and drop it, you see, for the library to bring new nodes, you just drag and drop them. And if I click on here, you see that now on this one, it creates still purple. So why it's purple? Because once again, it's vector information. So it's mostly the red and green channel that are showing a direction. And now if you look at the object, I'm going to push a bit to 10 because by default it's a bit weak. You see that it does as if there was some asperities. Meanwhile, it's completely flat. But it's a way to trick the engine and to give nice effects. By the way, to make the rotation of the light here, it's a Control-Shift right click. Once again, if you have any question at any point, just tell me. Then, okay, we can define the color, we can simulate a relief, and you can also change the roughness, meaning that you can define if it's matte or shiny. And once again, here you see a color, but you have to think of this as a value, which means black will be shiny, like this. So you see that I don't see black here. It just controls a parameter, an aspect of my material. And white is matte. And notice that if you look at the, let's put that here. I'm going to open a bit. Okay, if you look at the reflection, one of the great thing about physically based model is that the amount of light that is bounced is exactly the same. It's just it's bounced in a different way. It's concentrated when it's shiny, and it will be spread out when it's matte, which is very important because it means that whatever the lighting condition, if your material is well made, it will work. Meanwhile, before that, it wasn't the case. For example, let's say like 15 years ago, when you were doing a material, sometimes it was working great on sunlight outdoor scene, but you had to change it completely to if you had an indoor scene. With this, as it's based on physical properties, it works in any kind of lighting condition, which is great. So let's continue. I'm going to put back to green here. You have a metallic map. So this is, you kind of guess what it does. If I push it to black, which means 0, which means no metallic, to white, no, I have a metalness map. I'm going to change the roughness a bit so we can see that now. Okay, it's like a mirror. So you could say, you may say, one of the question that, okay, why? Okay, I have a metallic map, it makes sense, but why don't I have a plastic map, a wood map, a rock map, for example? And that's a fair question. This is, once again, because of physics. You have to know that every material that exists will let enter a fraction of light within themselves before to bounce it. Every materials except metals. If you take an aluminum sheet and you want to look the sun through it, even if it's like a fraction of a millimeter, you won't see the sun because the light doesn't pass at all within metal. So that's why in physics you separate metal and non-metal. And by the way, non-metal are called dielectric. It's the right term. And we had to represent this in the material properties. So that's why you have this metallic channel. And one thing also is taking this in account. Generally, in theory, it's either metal or not metal. You don't have value which are within both. Of course, there are exceptions. For example, if you have some dust on top of metal, well, you won't model the dust. And there is still some light that are going through. So in that case, yes, you can take an in-between value, but these are corner case. So take this in account. So going back to normal material. And finally, the height map is a map that allows to change to deform the mesh and to give some height to it. Meaning that if you are black, you are going to stay at the bottom of the height map, but the lighter you are going to be, the higher the mesh will be. We are going to see this in this example. So that's how, with everything combined, we are building a material. And as I said here, why these are images. Right now it's not super interesting because these are plain color. It could be almost like a slider and it would work. But most of the material that you have around you, it's not like that. If I take, for example, let me check. I'm going to put my... Hey. So if I put myself here, you see that you have lots of information. So I cannot use a uniform color to represent that. That's why we are using the textures. And this one, because you can add variation. For each pixel can be a variation. So we are using a combination of 5 textures that are plugged in outputs. So these outputs are what Substance 3D designer will generate at the end for the final user. So, and this generated map will be used by the shader to represent whatever you want. So here by default, when you open the software, you have this one just to avoid having an empty material. But we are going to replace them one by one when it makes sense, except the metallic one, because what we are going to do today is this material. Let me check this one. I'm going to try to represent like a tile ceramic, an old tile ceramic. This is an image that I found online. It's quite easy. So we're going to try to learn by seeing this. Okay. So talking back about the node a bit. The first thing I want to show you is in the library, you have many kinds of nodes. You have hundreds of them in different categories. I don't even know myself all of them, but that's not a big deal. As many software, maybe you are going to use 20%, 10%, 80% of the content, 80% of the time, and that's fine like this. And by the time you are going to see a new tutorial, or you are going to browse a bit and find a new node and find a new recipe to use it. But we are going, and the way it works is it's a bit like this. I don't know if you remember this cake game that there is in Windows and also in many smartphone app. It's like a chain, and you have a cake, which is you just have the base at the when you start, and then you are going to add some chocolate on top of it, and then some fruit, and then a topping, and then something else, etc. Well, designer, it's the same logic. You are going to take a content, and then on this content you are going to deform it, and maybe you are going to duplicate it, and maybe you are going to deform it again, etc., etc., until you get the results you want. So the library is really cool to find content, and you see that there is like many things, but what you have to focus on mostly at first is the generators and the filters, which are I would say the most important ones. At least you can make lots of stuff with that. What is the difference between a generator and a filter? A generator is something that generates a content directly. If I go in the noises here, if I take this, it already generates something. So that's why it's called a generator, because it doesn't need anything to work. It works by default. Then you will combine it with filters. Filters is something that will take something as an input and modify it to give a new result. Like, for example, if I take like this quantized grayscale, if I put it, you see that it has some parameters here, and in that case it just reduces the amount of color that you have. But once again, while this generator doesn't have an input because it doesn't need anything, this quantized grayscale has an input, and it's really important. It even has two because it has different capabilities. All of them, if you look at them, they have an output because they are made to be chained until the only one who doesn't have any output, it's the output nodes, because this is the end of the chain. This is what would be output by the node. So this one, there is nothing at the end. If we go back here, what I want to show you, I'm going to show you how to create nodes. So we have seen that we can do this, of course. But if you know the node, for example, that you want to use, you can also press spacebar or tab. They are the same, and it will give you this menu, which is a shortcut menu for the nodes. So by default, there are some of them here, like 25.6, which are a bit special. We are going to see why. But if you know, for example, I want a noise, you see that you can search and find a noise that you like and bring it here, for example. So by the time you are going to see that if you type noise, if you type grunge, if you type warp, if you type blur, you are going to get used to some words that will guide you through the possibilities of the software and the nodes it can offer. Another way to create, there is another way, but I'm going to show you just after. First, what I'm going to want to show you is something about how to plug node. So I'm going to take a blur HQ grayscale that we have here. So how do we plug them? It's easy. You just click on one side, on one input, and you press on the other one, and that's it. If I select with left click, once again, you can delete it. And you see that it works the other way around as well. That's important. And if you look at the color, you see that this output and this input are gray, and it works great. But it's not always the case. If I take a blur HQ color here, you see these are the same, except you see that here it says grayscale, here it says color, and you see that the color of the input and output are different. Why? Because it shows this one is a color node, which means that a grayscale node like this one has one channel, which means it has value from black to white, but on one channel. To represent color, we need 3 channels, and there is a fourth one in bonus for the alpha. So it will contain the potential transparency of the image. But you have to retain that for color you would use it this way, but these are 4 channels, so they can be used the way you want. Sometimes people are putting different information. what is important in our case is that if I try to connect it, you have this red dots link which say there is a problem. So it will still work, but for Substance 3D Designer, it will think, okay, there is nothing here, and nothing is 0, and 0 is black. So that's why the result here is black. So when you don't plug and it's expecting something, by default it will say it's 0. So really important, don't put a grayscale output in a color input, and the contrary is true, don't put a color output in a grayscale output. You have ways to convert it in case, for example, here you have you would use what we call a gradient map, which is something made for something else, but you see that by default it has a grayscale input and a color output. So if I do this, you see that it makes the same result, and now it works. In that case, there is a rule: if you have the choice, try to stick to grayscale. Why? Because grayscale 1 channel, color 4 channels, so it's 4 times more expensive to process. So in that case, for example, my colleague would kill me because I'm just making a blur in color for nothing, because I can use directly this one. So I'm paying the price of 2 nodes for nothing. On the contrary, if you want to convert to grayscale, you see that here I have a problem, but by the way, I'm going to show you something. If you select and press spacebar, you can directly insert in the link. For example, you have a node called grayscale conversion here. So this will turn a color input into a grayscale output. This, you may want to use it sometimes. Once again, make sure to stick to grayscale as much as possible. And by the way, I think there is an auto conversion node that I like, but I think it's good to when you begin, but sometimes you want to deactivate it. I don't know where it is, but I think in the graph here. Yeah, automatically insert color grayscale conversion node. So this will, if I do it now, and if I try, for example, here, I'm going to do this, you see that it directly insert a node. I think it's good, but there is big debates about this, so I'm going to leave it just because I like it. Okay, so if you look at the node, as we said, you have the properties here, instance parameters, so they are specific to each node. You also have base parameter, which are the same for any element of your graph, including the graph itself. So you have the output size, you have the pixel size that we won't see, it's not that used. Pixel ratio either, not that used, but what is important here is the output size. You see that it's right now by default, if you look for the nodes, or for this node, or if you look for the graph, here it's parent multiplied per 1. So this is a notion that you have to understand. When we say parent, it's parent app. It's the application that will use your material, because what you are doing now is mostly be used somewhere else, maybe in Painter, in Unreal Engine, Unity, Stager, I don't know, but it will be used somewhere else. So when we say that, we say, okay, what is the size of this material? Well, it will be the size defined by the parent application. In that case, multiply per 1, which means it will be the same size. This is what we want in 95% of the case, because if you set up, for example, in Painter 124 pixels for the size, you are expecting your material to be the same size. You don't expect it to be 248, for example. So that's why by default, don't touch it. Here, for example, if you want to try the parent size, because right now the parent is Substance 3D Designer itself, you can try it here. So you can change the size and see, you see that if I double click on it, it will regenerate the size. So you can specify it for the graph, of course. So once again, if you have a doubt, leave it like this, don't touch it. But you can also for a node. And for example, for a node like this, you can say relative to parent. So the parent of a node is the graph, so it will be the same. It's like a hierarchy: parent, application, graph, and node within the graph. Absolute means that you absolutely want to define a fixed size. For example, you want I want 124. Generally, this is not a good idea, because once again, if you say in another application, okay, 512, and it's 124, you say, what the heck? I'm trying to change, it doesn't work. So once again, absolute, it's really rare. 95% of the cases, once again, you are going to want to stick to relative to parent. There are some cases where you want relative to parent to be divided, to divide the texture. For example, if you have a small rock that will be spread out in the whole texture, maybe in that case you say, okay, the small rock itself, I'm going to divide the size by 4, because it will take a fraction of the texture when it will be used. So it's just a way to optimize. But once again, at the beginning, I would say stick to relative to parent multiplied per 1. No question in the chat so far, that's good, so I hope I'm clear. Okay, so we are going to build this material, and I'm going to introduce notions while we do that. Generally, when you want to make a material, the first thing you are going to do is to look at some references. So here I'm a bit light, but still, I have this one. And it's important to look at it and try to describe it a bit for yourself. So here I have like a ceramic, an old ceramic tiles, seems to be like a variation of colors. And I have at least 2 main elements, which are the ceramic itself and the joints. So that's good to know. So I know that I will have to make ceramic and joints at least. So I'm going to write it. So to do that, I'm going to do spacebar, as I told you that it allows you to reach any kind of element. And I'm going to type something, comments, like this, which allows me to write a comment directly within my graph. And it can be used for many things, but I like to do this to start organizing what I'm going to do, like a to-do list. So when I do this here, I can go in the description and I will say 1 ceramic tiles, 2 joints, like that. And when you click somewhere else, it will be here. So it allows me to organize myself a bit. And I'm going to explain you Mao. So the question is, what's the best way to proceed? To me, there are different schools, but to me, the best way to proceed, and for many people are going, is to start with the height map, the height and normal map. But as you are going to see, when you are doing the height map, you have the normal map for free. So why? Because, hey Amina. Oh, hey Amina from Mongo, if I'm not wrong. I am not even sure if it's the same. The first name is good, but so one of the things I like to work, yes, with the height map first, because this will give the shape of your material, and you have to think as if you are going to do to make a 3D print, for example, of your material. Well, you can almost guess if you do ceramic tile and you would say, okay, I'm going to 3D print it. You would be able to say, okay, yes, it looks like a ceramic tiles. The color is not here, it's not the right one, the roughness is not the right one, but still, you can see, okay, the shape is right. So that's why I like to start with that. And also because from these height maps, you can derivate a lot of information, and this is actually one of the strengths of a Substance 3D of Substance 3D designer, the fact that you can reuse stuff. Looking at something. Sorry. No. Okay, fine. I was looking at something about Amina. I had a doubt. Let's continue. So, as I told you, Mao, we are going to start with the height map. But first, we said once again ceramic tiles and joints. So I'm going to organize my graph a bit more. Or maybe, yeah, I'm going to do it right now. No, maybe later. So we're going to do the ceramic tile. So I'm going to do a frame. I like to do that. So a frame, once again, is to organize my graph. It won't affect anything. It's just a square where you are going to put nodes within it. It allows, once again, to organize a bit your work. Ah, yes, I was sure. I had some doubt. So hey, from Mango. I said another. I think I said another brand. I'm tired. Okay, so frame. I'm going to do 2 frames. So you can do Control D to duplicate any element. I'm going to do like this. This one will hold my ceramic tile. I'm just make one here. I think I like that. And as the ceramic tile is red, I'm going to help my brain a bit. And here we are going to do make a second one. Joints, and my joints were white, so I'm going to make this something like around that. You see that you can choose the color, you have the saturation, and let's do something like that. That's just to visually organize a bit how I'm going to work, and also it allows me, when you go back, for example, the day after, okay, what I've done, what I still have to do. That's really like a to-do list. Not everyone does that, but I like to do it this way. So let's do here. And ceramic tiles, where if you look at ceramic tile, it's a square. Here it's a bit used, but we are going to see if we have time, but at least it's a square. Unfortunately, we have a node which is called shape. And this shape, when you click on it, I'm going to unfold the instance parameter. You have some parameters like almost every node. And one of these is the kind of shape you can use. So if I look at here, you can go down the list with the arrow and you see that you have different kind of shape with, and you even have the mathematical name if you want to play Scrabble, and like gradation, paraboloid, a torn, bell, etc. In our case, we want the square, and I'm going to change the scale a bit to diminish it to something like this. So, as you may have noticed, if you look here, you have some square as well. These are nodes. So if I click on it, it will create a node, but there are not all of them here. And if I do spacebar, I also have the same node that here. And if you look, they are also here in atomic node. So these nodes are special. Why? Because they are hard-coded. This is like the DNA of, won't use this one. These are the DNA of Substance 3D Designer. Everything derivates at some point from these nodes. So, and when I say derivated, what do you mean? Because this is a node. So actually, this is called a node because we are going to use it this way here. But this is called, this one is an atomic node, and this one as well. This one, or let's say this one, everyone which this wine red title color are graph instances, which mean that this is a graph within a graph. And the difference is on this one, I can right click and click on open reference. So it asks me if I'm sure. Yes, I am. And you see that now I have new references here. And oh my God, it's done this way. I never opened this one. That's funny because I would have done this way. So you see that this is a graph that we encapsulated, so with a switch here that allows you to choose between the shapes, and then you have an output which will output the result we have in my graph. So I'm going to close it. So this one, what is a graph, and is a graph instance, and this is one of the strengths of a Substance 3D designer, because it means that through the years, more people have made some tools, and also the team has made some tools that will enhance the possibilities of Substance 3D designer. So every year, we'll say there is new content, new tools that make the life easier. For example, we just released all the 3D paths that you can use within it. And these are graph instances made by Nicolas Verman, lots of talent. And so that's why, just so you know, if I right click on an atomic node, I cannot go within it because it's just code. But this is the DNA, everything derived from this node. This is for your culture. So we were at the shape. So okay, I have the shape. And as I said to Mao in the chat, I want to start with the height map and the normal map. So the height map, in that case, it will mean that, let me check that. By the way, you can do spacebar here. It will tile the node. So going back to the shape, I'm going to change the scale. Okay, I'm here. And you see that I can adjust a bit this, and it will give me an idea of the future tiling that I can use. So I'm going to put like 0.95. And just so you can see, I'm going to use another primitive here, object primitive, because I want to make a floor. So I'm going to use the plane high res. So as we say, the height map will deform the object, which means that the lighter, the higher, and you are going to understand now. So first I'm going to plug it in the height map. So I know where it is, it's this one. So I click once and I go here and I replace directly the link. And you say, okay, nothing happens, but instead, in fact, something happened. If you look closely, oh, I have to do, if it doesn't work, just do view output in 3D view. And you see that something happens. I have to change a bit my material, but we'll see that later on. Roughness is too high. Okay. Okay, the geometry has changed, and you see that indeed the black part on the border did not move, but this one does. But we don't see the shading. That's real. This is because in Designer, to see the shading, you need to have the normal map. So luckily, this is the same. You are going to generate the normal map from the height map, most of the case. So here, you see that now we can see the relief. That said, I have black and white, and this is important in the height map to use the maximum amplitude, but you also want this object to reflect the size, the height you want in the real life, because this square has 100 units of each side, but 100 units doesn't mean anything for you, because if it's a tile like this one, I would say that it's 20 centimeter tiles. Okay, this 100 unit makes 20 centimeters. But if it's a door or a wall, maybe this 100 unit can be 3 meters. So you have to adjust a bit. But to do this, you can go to the material, and we are going to adjust the height scale. This is really something that is just to visualize within the 3D view. So height scale, so we see 20 centimeters for 100 units. So it means 2 centimeters, 10 units. I want half centimeters, so 10 units divided by 4, it means 2.5 units. So at the moment I will put that. I think I'm good. Yeah, you see, now it's higher, and it's more or less what I want for a square tile. This is something that I will change by the time, because after I will add more ceramic tiles, but at the moment that's fine. Okay, so that's fine, but you see, I have a problem, is that this is completely squared right now, and this is not what I want. What I'd like is like a small curve here. So once again, this is like a mental gymnastic. You have to think that if you want a small curve, it means that you want some gradient here, which means that the value that doesn't go straight from black to white. You want like a profile, a curve, a bevel, or something like this, which means like different variation. I would say 50 shades of gray, but it would be more like 256 shades of gray. So we are going to do this now. So to do this, well, that's easy. How can we add some shades of gray here? We just have to add a blur. So by default, if you press the node, I'm going to show you. Well, first, I'm going to do not select the node and just press spacebar and press and write blur. So there is this one which is an atomic node, but the quality is not that good. It's made to be performant, but I would recommend to take the blur HQ grayscale because this is grayscale, and I'm going to plug it. So if you see by default it's black, we don't see, but when I will plug this, bam, you see that now we have some gray variations. Let's say it's not visible here. Why? Because it's not plugged, it's still plugged here. So we have to replug here. So to do this, there is a shortcut that you have to know is you hold shift and then you can move it like that. And now you have it. And you say, oh yes, but it doesn't work. But that's the beauty of Substance 3D Designer, is that you can change and tweak everything at any time. And here, if I want to reduce this, well, I just have to reduce the blur intensity. So I can start from 0, for example. So no blur, and just push it a bit up till I have something that I like. And something like that is not bad. I like the width that it has, but I don't like the shape here. Fortunately, there is a cool tool to fix that. So if you want to fix this, what we can use is a curve node. So I showed you how to replug a node with shift like that. I'm going to show you another technique. If you select the node here and now you do spacebar, and I'm going to type curve. If it can, it will try to insert it within your flow. So here it make it for you. And you say, okay, fine, but it does not work. It doesn't do anything. And by the way, if you click on any node, you can disable it just to check before after. So it's Shift D. Here it's deactivated, activated, and you see that there is no difference. This is super great to test the contribution of a node. And you are lucky because I didn't show to the two previous live streams. So, curve node, if you know the curve into Photoshop, this allows you to remap values to a new value. For example, you can make it brighter, darker. In my case, here I want it to be, I want the low value here to be brighter, to be a bit upper. But this is really visual. If I do this, it will create a point, and now I can move the point, and you see that when I move the point and play with the Bezier curve, I can get something that is close to what I want. I'm going to do that, for example. Okay, so this is satisfying. It's not perfect, but today won't be the day of perfection. It's just to show you what it can do. So you see that this is just my height map, and once again my normal map is generated for free each time I'm changing that. We can notice also that this one is useless, so I just select it and delete it. Okay, awesome. Now I've made my ceramic tile. What I want to do is to duplicate it. So I made one. Now I'm going to make a new. I'm going to duplicate this 4 times by 4 times to have a floor. So I'm going to make a frame. Let me organize. And I'm going to call it floor. Ceramic floor. Okay. And in order to duplicate an element, there is a different one, but if you type tile, there is like tile generator, tile random 2. One of them which offers a lot of control is the tile sampler. So, and you can see that for each of them in most of them there is a grayscale version and a color version. So I'm going to take this one, and you see that this one has a lot of input. Why? Because it offers a lot of controls. You can change many parameters based on grayscale maps. So it means that at some point you can have a really strong value and a weaker value at another point. But in that case, we are not going to use, we are just going to use the first one, which is the pattern input. So let's look at this node. You see that by default, it's repeating a square like that. And if you would take the time to calculate, it does 16 by 16. Maybe you want to calculate, or you just want to look here on the right and you see that you have the value just here. In my case, I want 4 by 4 because we are not going to make a big one. You could make something bigger like 8 by 8, but for the sake of visibility during this live stream, we are going to stick to this. And I have a square. That's not... I want a square, but I don't want this square. This one is the perfect one. Well, if you look at this node, you see that you have lots of sections. You have a pattern section, which allows you to choose the pattern. And you see here that we have the same list than in the shape node. So I can go repeat different kind of shape. But what I want is to repeat this one. So luckily, the first one is pattern input. And that's what we are going to plug. So if you look here, you may have guessed you have pattern input 1. That's the one we are going to use. So now we have it. We can see the small gradient here. That said, when I was looking here, I had like a really thin joints, and here it looks quite big. Why? Because by default, if you go to the size, it's 0.8. It puts for you like a small margin by default, but we don't want it, sorry, because we already had it here. So I'm going to go here and change the scale to 1. And now I got what I want. So this is interesting, but you can see it here. But we are going to do Shift and replug, and you are going to do this a lot of time while working. And by the way, as I told you, I'm going to readjust directly the height map. Why? Because now, before we were like, we said like 100 units was making like 20 centimeters, but right now it's 80 centimeters. So it means that the height is too strong for this. So I'm just have to divide by 4 to be 4 times less important. 2.5 divided by 4. I think it's 0.75. I think because I calculated 2 times before. The scale, let me check. The scale will define the bottom and top point. The level will define where does it start. So it will say, for example, if you choose like it's really the starting point, meaning that you can start from the black 0 value, or you can start for the 0.5 value in the middle, for example, and then choose the amplitude. I don't know if it's clear, Ermina. No, it's a Z spider, sorry. To give you an example, for example, I'm going to do really quickly a gradient like this. So imagine this is the height map value, and I'm going to do histogram select. Don't retain the nodes for now, but this is something that this would look like that. So if you choose the 8 scale, it would be this. So how the amplitude of the scale, and the other one would choose where it starts from exactly within this amplitude. So I hope it helps visualizing a bit how it would work. Let me go back here because I changed it. 8 level 0, okay, why not? Sometimes we like to start from 0.5 because, for example, in Painter, sometimes you want to go up or go down. Well, I'm answering while reading your question. For example, in Painter, sometimes you have a surface and you want, yes, to go through within the material of the previous material, and sometimes you want to go up. So in Painter, they all start from 0.5 because you don't know if you want to add an information or add volume or subtract volume to your material. That's why we would start from 0.5, for example. Generally, it's this or 0. What is really rare is to start from 1. This is almost does not happen. But Painter, you always make sure it starts from the middle. It's by convention we do that. Okay, so here I say a scale 0.75. Okay, so I have a tile, square tile. That's not exactly what I want, but that's a good base. So before to continue, we are going to see how we can make the joints within it. Just to advance a bit, my joints are here. So this is fairly easy. A joint is like a granular, flat surface, white in that case. So I want to show you that sometimes it can be fairly simple. Just going to take a noise, and there is a noise that is really useful, which has an horrible name. It's the fractal sun base. So this is a node which is really handy because it allows to make a lot of variation. So far we are going to leave this tile like this, and what I'm going to do is to visualize this noise. Okay, so we have it, and this is cool by default, even if I'm going to explain why it's cool, because you can define the repetition, the granularity, and the frequency of the material. You're going to see why. If I put both to minimum level, you see that it makes big wave. But if I go to the max, it will mix the big wave with the smaller one, and you see that there is still underneath some big huge wave. In my case, as it's a cement which is really thin, I don't want this big wave, so I can increase the big level until I got something flatter. I can see the result here, and as you will see right now, at the moment, this is way too strong for what I want to do, so I think I can change the roughness as well, like that, but I don't want it that rough. You can change the global opacity. In my case, you see that the opacity also control, as it's in the height map, it changes how high it is. That said, I'm going to control it in another way. So let's say I'm satisfied with that, which is not the case, but now what we want to do is to blend them together. So blend, how to blend? Well, with the blend node. This is a node that you're going to use a lot, and which works a bit like in Photoshop. When you have one layer on top of the other. So this one would be the one layer, this one would be the on top of the other, and this would be a mask for the top layer, which means that when it's white you will see the foreground, when it's black you will see the background. So let's blend them together a bit. I'm going to do it this way. Let me think 2 seconds. I'm going to show you 2 techniques actually, because there is this one which works great. So I'm going to do shift to replug here, and you see that it keeps the link here. By default, it's replacing everything. The top layer is covering everything, so we just see the tiles. But we say that if we use a mask where it's white, you will see the top one, and black, you will see the bottom one. So we have this mask. This is the tiles itself, so we can use it. And you see that now it can be used to see the tiles. And I want to try one with you, which is the height blend, which actually look at the height intensity of each map to place everything. So let's try it. So here, so this is really made for height blend, for height map, sorry. Height map. So now you see that it works and they are tied together. That's it. To me right now, it's too high. So I think I have the control here directly within the node. You can define that. So I'm going to put this at the top like that. And in that case, it will be easier to use the height blend because it will create the right proportion between both. And as I said, I don't know if it's Mao who has this. That's why I'm working first with height and normal maps, because doing this, I can make sure that, okay, does it look right? Does the shape of my material looks right? And does, if it was a 3D print, would I recognize that it's a tile? Probably yes. So you will see that the color and roughness, I'm going to do this at the end. Even if the roughness is really important for the believability of your material. But first, I like to focus on this. So let's continue now. Okay, I'm quite satisfied with this. Maybe here I want to diminish a bit the strength of that. So to do this, if I were in Photoshop, I would use a level node and do something like that. And I would diminish the value here, maybe here to diminish the amplitude of my of the grayscale variations. It works, but as we're in a designer, we build some tools which are specifically made to play with these parameters. So here, what I can do is type histogram. What we call an histogram, you know, it's the representation of the grayscale value. And we made some utilities which are extremely useful in that case, especially the range one. So the range allows you to diminish the range of the grayscale value. So if you put 1, you will have the same result. If you look, I do Shift D, and you see that when it's on 1, it doesn't change anything. But if I put on 0.5, oops, you see that now you see the influence. So I'm going to diminish because it has to be quite thin, honestly. I don't want something. It's important to be subtle. One of the defects sometimes is when we're working on it is we focus too much of what we want to put, and we put it too strong by default, because as we want to make it, it's too strong. And when you look back, sometimes it's good to look from far. This is almost invisible in a real one. It's even too strong maybe. So 0.1 I'm going to do. Okay. Now I'm going to add this, one of the problems with procedural modeling like this, or procedural materials, is by default they are too perfect. And this is the case for these styles. But that's the great thing with Substance 3D Designer. If I can go back here and continue and improve all of that. So let's do that. So first thing I'm going to do, I'm going to add some defect to this. To add some defect, there is many different ways, and there is a family of tools which are called the warp tools, and also the slope blur, some blur, which works pretty great. And in my case, I'm going to improvise a bit with you. I'm going to start by making this warp is good, but it's too strong by default. I don't like it. You can try it if you want, but it heavily destroys everything. So first thing, I'm going to add some noise, because if I want to warp something, it won't work super great with just black and white values. So let's look at the noise we have here. And let's choose something like, I don't know, something like this one, grunge, rust, fine. I don't know if it will work, but we'll try. It will give something anyway. And this I will use to warp the. First, I'm going to blend them together. So I am adding some information here. So blend, we put a blend node. I'm going to put the curve as the background. The tile as a background, this as a foreground, and I'm going to go to multiply. Multiply, well, it does a multiplication, so it's values between 0 or or 1, so it will just, all the white will be multiplied by this, so it will be, white is 1, so it gives the same thing. So if I just do this by default, it's way too strong. Of course, this has to be really fine details. So what I'm going to do here, selecting the blend, you see that you have an opacity channel. So I put it to 0, and then I'm going to increase it progressively. If you want to be subtle, you can hold the shift key and then go to the right, and then you will have some value. Hey Cloud Lucky, I'm reading to your question. Well, this would be to watch this live stream from the beginning, because that's exactly what I'm explaining right now. So if you want, what's the best way to start with Substance Designer for beginners? It's to watch this live stream, Introduction to Substance 3D Designer. I think at the moment I cannot give a better lessons. So I'm just explaining everything from scratch. In case this is recorded, it will be available live directly when it ends. So if you don't want to see, that's fine. So here I have these details and I don't want more. You see, I'm at 0.02 and that's fine. I may add more later on, but here I have an issue. If you can see that, okay, I made it. Here you can see it, but you can see it in, if we go in the normal map, you can see the details. It's easier to grab, but there is an issue. If you look here, this one and this one, they are exactly the same at the moment. So that's not exactly perfect. So a good way to break this effect is to go to the tile sampler, which is here. And if you go to the pattern, you have some rotation random, so it would make like some 90 degrees rotation. You can see better in the 3D viewport, I think. And you also have like symmetry random, which will make symmetry between both like vertical or horizontal. So it allows to add some variation for free almost. That's a good one. And maybe I want to destroy a bit more and to remove some parts. So I'm going to do another warp, I think, based on that. But maybe in that case, I'm going to make it on this part. Let me think. I'm going to make it on this, but I will have to filter so it doesn't affect this. First, I'm going maybe to break a bit the border. So to do that, I can do that with slope blur, for example. There is different technique, but the slope blur grayscale is a node which is quite effective. So let's take that slope blur, and it needs another input to define. So I'm going to start with the Perlin, and you will see what it does. By default, Perlin noise. Making it, and you see by default it breaks everything. So first thing to do, increase the sample and put the intensity to 0. Okay, because it's way too small. And here I'm going to look, and I just want to break the here, so it will act on the gradients here. So let's move that, and you see that really quickly it's too strong. You see, even here it's too strong. So first I'm going to go to the Perlin noise and diminish the scale. And maybe just that is enough. And so I broke a bit. That's fine. It's not too visible. Maybe from here it is, but that's fine. You know, I don't want too much. And what I will do is, as this is good, but it's too soft, I'm going to break the noise itself. So I'm going to use a warp once again. And maybe I'm going to use multi-directional warp, or new one, non-uniform. This one is strong. I did this one, so I like it. It was improved then by Nicolas Wehrmann. So the first input defines the intensity of the warp, and second will define the angle. So I'm going to take a noise once again, like whatever noise will be fine. I'm galvanic, and let's see how it goes. So by default, it will be way too strong, I think. Okay, this. I do X to invert and to see if I like it or not. Let's see how it goes. Oops. Okay, it's not okay. It was unplugged. That's why I said that's free and it doesn't do anything. Okay, so here it goes. Let's diminish the intensity. And now way too strong, so we're going to fix that. So does yeah. First we have something, and here I'm going to change a bit the intensity. I'm just removing a bit here. So this is just playing sometime just to see how it goes. Way too strong. Okay, so let's see. Got something. My slope is here. Okay, so I'm going to diminish that. And to diminish that. So these are adjustments that you can do later on. .1 should be fine. Okay, let's go with that. Finally, what I want to do, I don't want a plain surface like this one. So I'm going to go here and use a node, a ceramic floor. I'm going to put that here. We are still in. A node called, so I'm going to go here. This is my everything that is generating my floor. So what I want to do is to add some variation in the angles because they are too perfect right now. So you can use a node called float fill, and actually this is a series of nodes. Oops, sorry. Here, float fill. So this by default is useless, but it extracts some informations that I'm going to use for each tag. You see that it managed to detect each individual tiles, and from this I can use some utilities like to get depending of the size defining a color, put some colors for each of them, put a gradient, a grayscale, a random grayscale, etc. So I'm going to use in that case the gradient, and what it does, it creates a gradient for each of them, which is great. So let's put it here at the moment, but it's great, okay, but that's too perfect. And you see that here it even makes problem with my joints. So I want this gradient, but I don't want them all in the same direction, and I don't want them that goes too deep. So we're going to fix all of that. So first thing, if you go to the fill gradient, you see that you can go to angle variations, and then it will give a different angle variation for each of them. If it would be sand, it would be interesting. And now I want to limit the amount of it. So for this, what I'm going to do, I'm going to blend with the existing one here. So blend. I put this as a background, this as a foreground, and I put the opacity at 0. I'm making sure that this is connected here with shift. And now I'm going to adjust, because once again you have to be subtle. You don't want to be more. I'm assuming that, so if I put up here it's too much. I just want just a bit. So 0.4 seems to be fine. And the cool thing is now is you see that it breaks the lighting. It has different kind of lighting for each of them, which is interesting. Okay, so we are starting to get something interesting, and once again I didn't touch the roughness and the color yet, and still we have something that starts to get interesting. Maybe right now that I'm looking, I may want to say, sometimes you can say, you know what, I want some more details. So I may put more here. That gives something even more interesting. That's something you want to adjust afterwards. And it seems to work well. What I'm doing right now, I like to have like a roughness, but at the value is 0.5, something like that. Let me check. Yeah, we are the 0.5, which allows me to see the reflection, the details, without being too shiny. This is a good way to work. Okay, so we have something pretty interesting. So maybe I could add more details if I want. This is really up to you to break even more here. That's something that you would decide. I may want, I'm deciding that, oops, sorry, that I want maybe to something a bit more breaky here. So let's go, I could do it here or I could do it there. Maybe I'm going to try to do it here. So what I'm going to do is take this and I'm going to make a warp once again. And I'm going to do multi-directional warp grayscale. And let's look at a grunge, something like that, for example. Oh, sorry, not double click. So by default, it will be a bit violent, I think. What I'm going to do, I don't want, oh, maybe we're going to see, I'm curious to see how it goes here. So, shift. Okay, we see that it's way too violent. But still, that's interesting because what I'm going to do, I don't want the joints to be affected. So I'm going to make sure that here the joints are black. So I'm going to reuse this where the joints are black. Blend. Here, multiply. And now let's see. Okay, so now it's interesting because it's breaking on my object without affecting the tiles, yet it's too strong. So, and even it's a bit grainy. I don't know if I like that. What? Change the warp angle. Change the intensity. Well, for this one, we're going to say that we are satisfied. I could add a blur here to diminish the impact. So by default, it's way too blurry, of course, but once again, you put to 0 and progressively you can improve. So by default, it's like this. And I could remove some details, so I prefer this way. Okay. And it's even too strong for me. Okay. Okay, so we are going to stop here for the height map and the normal map, and I'm going to change the height offset, something like that. And now we are going to proceed on the coloring. So then when I do the height map and the normal map, I am making the coloring. Why the coloring first? Because in that case, I have the feeling, if I look at my reference, that the roughness, which means the variation in the parts which are shiny or matte, are affected by a varnish that went away. So that's why I want first to make this kind of color. Then I'm going to focus on from this color and the mask I would create, I will derivate the roughness map. Hope it's clear. Everything is clear so far, more or less. No one is crying while watching this. So for the color, I'm going to make sure to organize a bit. This goes here. I'm leaving that here because I want to know where this is my hide plane. This is very important. Oh, and my cat is coming here. So color. So if we look at the reference, it's like this kind of orange, reddish orange, ceramic. There is a lot in Spain actually. So let's do that. So how to do that? So as we can see, there are some variations, etc. So I'm going to look first at a noise, black and white noise that looks a bit like that, if any. I'm going to start with the cloud 2. It's not exactly the same, and but it will make the job. A thing, by the way, that by default, if you open the cloud 2, you should have something similar, which is a shame because it's procedural, so which means we can have a full amount of variation. But luckily, for any node, if you go into the base parameter, you have a random seed, so you can change from 0, 1, 2, 3, 4, 5 up to 10. But you can even more actually, because if you do this, chances are someone else will do it. So what I'm inviting you to do is to use this button, and here you will have a unique number that no one else will go. So you will have a unique noise. So I'm taking this one and I'm going to colorize it. So how do we colorize it? We are using a node that we have seen before, which is called the gradient map. So what it does, this node, it remap gray value to other value, whether grayscale if I want, or color in our case. And you see that if I change from one to the other, the output is changing as well. So we want to be in color, and I want, well, how does it work? So I can click here, but if you open the gradient editor, it's even more visual. So if I click on the gradient, you see that it creates two sliders here. And for each slider, I can choose the color, and I can say, okay, for this black value here, I want them to be red. And now it will remap the color, so any black place will become red. And if I do the same here with blue, for example, well, you get the point. It makes a gradient that it remaps the grayscale values to fit with this. So in our case, we have this, and we want to remap more or less this way. So I could make it by hand, or as well, I could use the color pick here, but there is a better way. So let me resize first. Oops, Substance Designer, something like this, and I'm going to make my reference here. There is a tool here which is the pick gradient, and it's awesome because when you use it, you click on it, you see that my cursor is changing, and now I can draw a line. So I hold the left key and I draw a line up to here, for example, and it will create a gradient for you. And you can define the precision a bit here if you want. As there is already a lot of precision in the color, I'm inviting you not to go too high. If not, it will break the effect. Sometimes people say, okay, I want a lot of variation, but it don't bring anything because you already have them within your map. Oh, sorry, mosquito wants to kill me. So I got something interesting here, even if I would say that I want some darker color. So first, what I'm going to do is going to the gradient editor, maybe remove that. Put that a bit later, like this. And okay, I get something interesting, but that's not exactly what I want. So what I'm going to do is I played with that. The colors are fine, let's say, but I'm going to tweak a bit my cloud so it's darker. So to do this, and also with more contrast. So I'm going to use another histogram node, which is the scan one. So by default, it's black. Why? Because it's everything, the position is on the left. So if you want the default one, it's 0.5. And I'm going to show you something, because here, I want to tweak here, but I want to see the result here. So what you can do, when I'm here, you can double click on one node, it will display it here. And to know what it's displayed, you have this icon. But if I do single click here, you see that here it means that the properties are this one. So now I can play with the position, play with the contrast as well to get something that I like. I don't want too much contrast in that case, but I want something like that, for example. And maybe I'm also going to add like a warp on this. Maybe I will try to warp it by itself. Multi-directional warp. It's a grayscale. Where are you? Here. Sometimes it works. Once again, I'm going to do this. Why not? Let's say we are satisfied. I don't want to play for too long because we have some stuff to see. But let's say I'm happy with this one. So I'm going to plug it directly on the base color. So let's say the color will do it here. Okay, so color is fine except that it's everywhere, and of course we don't want that. Well, we have some masks here that we can use, so we are going to use that. Maybe this one, because there is like, we made some changes, but we have to adapt. So let's make a first pass. For the joints, I won't take, oops, sorry. We say it's almost white, so what I'm going to do is to take this and once again use a gradient to make subtle variations. So gradient map here, and what I'm going to do to show you something is I'm going to show you how to make a portal. So I'm going to put that here, and in that node, if you do alt click on the link, you can add a dot like that, which allows you to place to organize a bit your graph to make sure that, for example, if you want things to be clean. And recently we had something which is a portal. So now if I add a second one here, if I define here a name for the portal, and I say, for example, joint, it will create a portal. You see that now it's still selected, so you have this dot link, but if I remove that, you see that now you don't have this big spaghetti between, it's just here. But you have I know it's the joint. So in the gradient map, here, now I'm going to define some color. So for black, I almost don't have black, I will say, take a yellow like this, maybe. I'm not sure, okay, it's here. Take something gray like that. And for the white, same thing, I'm going to get close to the yellow and something like that. Not that much. Okay. Oops, no, I don't want to do that. Okay, so now let's blend that together. So to blend, the blend node, as always, putting this on the back, this in the front, and now I need a mask. So this is my mask, but we'll have some problem because you see that there is a gradient. Here it's a bit better, but still there is a gradient. But what I'm going to do is still use that for now. I'm going to plug it to see the issue. Okay, I think it's clear. It's so clear. Okay. Like that, you see that we have some color. Even if it could be interesting, that's not what we want. So what I'm going to do is here to add an histogram scan to increase the contrast. So I select the link, histogram scan. Now I'm going to put this to 0.5. And now I'm going to push the contrast a lot. And I'm going to move that until my mask is black and white. And now you see that it makes something great. And actually, I may use this to diminish the contrast because let me save them. Okay, it was making some interesting variation in my opinion. Yeah. Maybe not that much, but okay. And here, I'm not satisfied with the color. I'm going to diminish the saturation. Okay. So this is cool. Now let's see to make the roughness map. So for the roughness map, well, as I told you, I want the roughness to be derivated like I want the darker zone here to be more shiny, as if there was a bit of varnish on top of it and that it was fading away for the other zones. So I'm going to use this again. Just first I'm going to make sure of something. Well, we can try anyway, but seems that the dark zone are the brighter here, so are these ones. Okay, we'll try. So I'm just taking violently this and directly plug it in the roughness, and you see that now you directly have variation, which are quite interesting by default, but that's not what we want. And by the way, before to do that, I'm going to show you a problem that we have. Is here you see that the color is repeating perfectly between the tiles while they are different tiles. So I'm going to show you a trick to break a repetition of a texture like this one. So we're going to do it on the mask, and we are going to use a warp, but a directional warp. What it does, it will push in a specific in a single direction, but with different intensities. So directional warp here. So I'm going to take this, and what I want is to define a different intensity for each tiles. To do this, it means that it's a different grayscale value for each tile. So if I'm going back here with the float fill that we made, there is another utility that you can make float fill to random color grayscale. And this is, you see, I have different values, different color, meaning different values for each tile. So if I do that now, you see that it will push in a different way for each tile, and I'm going to increase a lot, 200 the intensity, and change the warp angle. You get something completely different. And you see that now you have like something completely different for each tile. Okay, seems to be good this way. So let's replug this. You see that now it's way more believable, but I have to change because this roughness map is way too strong, so I have to, and way too contrasty. There is like really matte zone and shiny zone, which is normal here because it corresponds to what we have. So the good thing is we see that the shiny one corresponds to the dark one here. That's what we want, but still we don't want this part to be that rough and this part to be that shiny. So to do this, once again, the histogram scan is our friend. So I'm going to select this link, spacebar, histogram range, sorry. And I'm going to diminish the range. By default, it divides the range by 2, which is great. But still, I don't want that much. I'm going to divide by 2 again, so 0.25, and I'm going to play with the value a bit to choose the position. If I want to go on the left, it will be shinier. If I go on the right, it will be rougher. So I'm going to take something like that, and just to check, that's why you are going to check with the value here. I'm quite satisfied. This is something that you could choose, but what I'm showing now is some techniques after for the artistic choices. You are in charge. I'm going to change my object right now to rounded Q so I can get a better aspect. Quite satisfied, honestly. It's quite clear. Maybe it's I'm going to add an histogram scan because I want more contrast. I could add a contrast, and you have a contrast node. Contrast luminosity, I can increase the contrast, but I have less control. So I'm going to take this and maybe I'm going to do it before. Here. Histogram scan 0.5, and now I'm going to increase the contrast a bit. Okay, so this is good. Just changing a bit the position, diminishing the range. Okay, and there is a moustique that absolutely wants to take my blood. Okay, so now we have done that, we are happy. Now, still missing something. I want to show you, like in the last 20 minutes, how to add some parameters and also how to publish your material. Sorry. So to add some parameters, so what we can control here, for example, let's say I want to offer the control on the color. So I could go here. For example, I have the gradient map. There is ways to expose the color individually, but in that case, I'm just going to add here a node. I'm selecting the links once again to insert. And there is a node which is called HSL that allows you to change the hue, saturation, and lightness. So in that case, I want to be able, the artist to be able to choose the hue of it. So how to do that? How to expose a parameter? So there is two ways. If you have one parameter, I would recommend, well, let's say first, if you have multiple, for example, if I want to expose the three of them, you can do right click on it and you have expose parameters. It will open this window, and here you can say I want to expose this, this, and this. You can put a prefix, a suffix, whatever you want, and it will expose the three. That's not what we are going to do in our case, because I just want the hue. So for each parameter, which are exposable, you have this small menu on the right, and you have expose as new graph input, which means expose the parameter. So I'm going to do that. Once again, I have a small windows, which is a bit more precise. You can specify more things. That's why I wanted to do this one. So first, the identifier here is, the identifier is the name for designer to work internally. Sometimes you can create variables and more advanced stuff. So this is a name that will be just used within your substance graph in designer. So I would say ceramic color. Once again, try to name it correctly. Label, it's for the user, so it's important. So ceramic color again. And here you can put a description. This defines the ceramic color, for example. You can, by default, it's a float. The type is a float, which means there is the integer and the float. There are different types, which means that it's a number with a comma. You cannot change it because it's linked. This parameter is linked to the parameter of your hue, saturation, lightness. You can define a default value here, a minimum value, a maximum value, and you can clamp the value, meaning that you forbid the user to go either below 0 or above 1, or whatever values you will define. This really depends on what you are doing. Sometimes you can, and it's okay, but sometimes it will break the effect. So in that case, I'm clamping it. And the step is just the precision when moving the slider. So let's do OK, and let's see what happens. So first thing here, you see that now the parameter is in blue, which means it has been exposed, and you can see that it's not available anymore at the level of the node itself. You also have this small button here, which is, it creates a function graph. We won't see that today, or we are going just maybe to look that very quickly. Then, if I go at my graph level to see the parameters, so you can click here, or you can double click in an empty space on your graph, and you see that now in the input parameter, you have the ceramic color. So you have the parameters here. So this is all the one you have seen before. You have some more here that we won't see today. You have a preview mode, which is really handy. It allows you to test without touching what you have defined in parameter. So if I go here, you see that it go back to normal, but that's really handy to test. So this work, we are fine. We have defined our first parameters. I want to do one a bit more interesting, in my opinion. I want to be able to add some dirt on this model. So how could I do that? I want the dirt to be on the cracks or the interstices, etc. So one of the way to isolate this, because what I have to do to apply dirt on a specific part is I have to create a mask that will correspond to this part. So I'm going to do that, and for this I'm going to use an ambient occlusion node. An ambient occlusion is exactly, it looks at the places which are self-shadowed by the object itself. For example, within my fingers, you see that it's darker because my fingers are self-shadowing each other. That's ambient occlusion. So there is a node really handy which is called ambient occlusion. So if you do AO, you have two. Well, you have cancellation, you don't want this one. This one is a bit better precision-wise, but both works well, honestly. So I'm going to take this one, and I'm going, what it takes as input to work well is the height map. It can work in other conditions, but this one works well. And you see that by default, it gives me something for a mask, which is pretty interesting. If it would have been just for ambient occlusion, I would have diminished the scale to get something more subtle, but in my case I don't want subtlety. And actually, you know what, I really like the fact to increase, because it seems to give me more details which are going to be interesting for my mask. I'm going to look at the maximum distance, spread angle. It doesn't do that much, but this is interesting to me. So I'm going to take that as a mask, and now I'm going to, I could be more specific, but I'm going just to apply dirt to the base color. So what do I need? I need this mask. I need a blend. I need a dirt color, so I'm going to create one here. So I'm just thinking a uniform color. Then I'm going to put maybe like a brown, like brownish something. You choose the dirt you want, huh? Like that. I'm going to put that here. By default, it replaces everything. And here, you see that it doesn't work. Why? Because it's upside down, meaning like my mask, where I want the dirt, it would be this part, but in my mask, it's plugged the way around. So this is on purpose, because what I'm going to do here is just invert the mask like that, and now it will work. So let's plug that. Okay, so I have dirt on it, that's cool, but how do I control that? And even it's too much, but once again, we won't get into the details too much. Actually. Okay. So what I want is to be able to control this dirt. So I'm going to use an histogram scan, which is extremely handy. Because what it does now, sorry, I'm going to put it here. After so histogram scan. So by default, it's black. When it's the position, it's 0. And the more I move, the more the dirt is going to cover everything. So that's the interesting part. Up to 1, which is too much, but... So I'm going to use this parameter here as my dirt control. So I put it to 0. Click here, expose, dirt. Well, why not use the dedicated dirt node? Why not? Why not? It could be used as well, but it was to show some controls. But yes, of course, there is not one way to do things. Here I'm using it just to show you histogram, how to make a mask. It's more for pedagogic purpose. Dirt, define the amount of dirt. The minimum, maximum, boy, I'm going to put like 0.8, or maybe I'm going to show I'm going to stay 1 and I'm going to show how you can stick between 0 of 1 but limit within the small function. It will be introduction to function. So I'm exposing this, and now going at the graph level, 0.5 for this one, and you see that you have the dirt. But once again, I don't want to be, I would like to stop up to here maybe. Well, that's fine. I'm going to leave it this way. Okay, so now we have a material, ceramic tiles, with, well, interesting detail that you have here. Once again, this is an example, and I really invite you to play with the warps, to blend noise together and try to see the difference that it makes. Try to stay subtle. The more noisy is a noise material, the more frequency, the lower. Oh, my wife is calling me. I'm going to refuse. I'm going to tell her that I'm in live stream, because sorry about that, but you know. So yeah, try to stay subtle. That's the quality. If you don't hesitate to divide by 2 to start from 0 and to increment, that's a good way to do stuff. So how to publish that right now? So you have some stuff before to publish to double check. You can go at the graph level here, and let's look at the base parameter. In theory, you don't have to touch. But here in the attributes, you have some stuff. You have the Substance 3D Designer name, the identifier, which is the same that here, but here you have the name for the user. So Dirty Ceramic in my case, for example, but that's the name that will be displayed in other application, or in Designer if you use it in another graph. You can define what type it is, because we made a material, but you can make filters and other stuff. You can define the physical size, and if you know it, it's good to define it, because it will be, another software will be able to use it to display your material properly. So in my case, it's like 80 centimeters by 80 centimeters by 0.5 centimeters. So let's do that. 5. You can add an icon, so either you have it or you can generate it here. So you just click and it will generate an icon based on your material, like that. Is it safe? It's not safe, which is bad. So I'm going to save right now my work, and my first graph, you see, this way I have it in 3 languages. I'm super happy. Going back to the graph parameters, you can add a description. This is a dirty ceramic. You can add a category, you can add your name if you want, if you have a website. You can add some tags, for example, if you can say floor, ceramic. If you do it for a project, you can specify, for example, you can say, okay, I'm working on a Far Cry 27. Well, you can put FC27, and for example, in the project, if they type this tag, they will see all the material related to the project. So this is a good one. User data, it's more advanced. If you work with a team where there are developers, you can pass specific data here that will be grabbed by a developer, and I don't know, it depends. It's really specific usage. So you can define all this stuff. Then we are almost good to go. So what you can do to publish, how you do that? You select your package. And here, I think there was something that I didn't show you, sorry. Attributes, here, these two. Expose in SBSER, yes or no. So what does it mean? Is this graph in particular visible? You may think, okay, yes, of course it is. But sometimes you have like 3 graphs and 2 of them are made for testing. So this one, you don't want them to be seen by the user, so you put no. Show in library, same thing. If you want them to appear here, you leave it on yes. If not, you leave it on no. So now, to publish, the easiest way, you select your name, package, and publish SBSER file. It will show you ask you where you want to save it, by default at the same place than your SBS. Yeah, like a Substance 3D package, it's a SBS file, only openable by designer. SBSAR is the file that you will share everywhere else. So you say publish, archive compression, you can leave on auto, and you publish, and that's it. There is this button now which is appearing. So if you make some change you want to publish again, instead of remaking that, you can click directly here and it will republish at the same location with the same parameter. And you can also directly send to another application. For example, if I do send to Substance 3D Stager, which is our staging and rendering app, you see that it will launch Stager, well, if it's installed, of course. And it will create a new project, because in Stager it's saved by project. Wow, these mosquitoes. I think he already has 2 liters of my blood. And now you see that it's here. I have my material directly in the project. So if I take, for example, let's take this cylinder, I can apply this on top of it. And you see that I have my material applied directly on it. So I can repeat, and more importantly, let's go ray tracing, it will be a bit better. More importantly, you can go here and you have access to the substance parameters. So I have the ceramic color here, wonderful, and I have the dirt, the amount of dirt that you can define here. Of course, it would work in any other application. Okay, so I think we covered most of the topic here. If you have any question, I'm going to leave the chat for 1 minute more or less to see if you have question about Substance 3D Designer. Of course, thanks Niraj. Of course, you can do way more. This is just an example. If you want to improve your skills, what I am inviting you to do is to look at the library here and try to play, to discover, to look at each category, especially noise, patterns. There is lots of stuff. There is adjustments which are quite self-explanatory, but sometimes you are not sure. Just try stuff, play with stuff. There is many stuff to do. My idea behind this live stream is to give you the basics. To give you the basics, so I can make more tutorial about Substance 3D Designer. So we can start at the same page and go deeper depending of the topics. I'm more technical guy, less an artistic guy, so I will show you techniques to build masks, to build filters, to use the pixel processor, FX maps, etc. I hope you like it. I don't see any question in the chat, so thanks for watching. And I'm going on vacation. In 2 hours, I am in a boat. So it will be. So it means that my next live stream will be in 3 or 4 weeks. I have to double check the calendar. Anyway, thanks again for watching. I hope to see you soon. And if you like this live stream, put a like, subscribe, share with your friends, and see you next time. Bye bye.